Hey everyone, welcome back to the channel. I'm Ehsan, Network Automation Engineer. As you see the previous video, we are going through the Juniper SRX firewall policy automation, and we have the Python code, and we have the devices and policies in YAML format. And I want to start the category of sessions that are just code explanation. And this is the first section of my code explanation sessions. And I want to start from Juniper SRX policy automation repository that you can find in my GitHub repository. And all right, now let's go deep into the code behind this automation tool. And in this section, I'm going to explain every important part of the Python code line by line so you fully understand how the automation works under the hood. Let's start. First of all, as you see in all parts of the automation projects, we have the imports section. The very first part of the script is the set of imports. These imports tell you exactly which building blocks the script uses. Here we import YAML, device, config, E3, and several exception classes that are some parts of the building blocks of the import section. For example, we import YAML to read YAML files like devices.yaml and policies.yaml. We import device to make a NETCONF connection to the SRX firewall, and we import config to enter configuration mode, loading the commands diff and then commit. And we import E3 to build XML filters for targeted config retrieval. And as I said, we import several exception classes just to safely handle errors during automation. And these imports define everything the script can do. Read YAML, connect to SRX, change configuration, verify results, and finally handle errors gracefully. In part 2, we have the coding function. As you see, we have here CLI code. In the next part, we have a small but critical helper function named CLI code. Its job is simple but extremely important. It takes any text, a zone name, a policy name, or an address set, and safely wraps it in double quotes while escaping special characters. Okay? This prevents the Junos CLI from breaking and ensures the configuration commands are always valid. It's one of those things you may never notice, but without it, automation would constantly fail due to minor syntax issues. After that, we have loading YAML files safely. The next helper function is load YAML list. This is one of the most clever and defensive parts of the script. It performs 5 levels of validation. It checks if the YAML file exists. It checks if the YAML file is valid. After that, it checks if the YAML structure is a list. After that, it checks if each item in the list is a dictionary. And after that, finally, it checks for required keys and normalizes the structure. If anything is wrong, the script stops because it's better to fail early than break your firewall later. This helper function makes the entire automation process safe, predictable, and controlled. After that, we will have the building XML filters by the interesting function build policy filter. Instead of fetching the full configuration of the device, this function builds a very specific XML filter that tells the SRX, show me only this policy in this from zone and this to zone. Why is this important? Just think for a moment. Because it makes the script extremely fast and scalable, especially if you have large configs or many devices. It also gives us precise visibility into whether a policy already exists or not. After that, we have the extracting existing policy details, and here the extract policy details function takes the XML returned by the SRX and converts a security policy into a standard Python dictionary. It will extract source addresses, destination addresses, application, the action, that is maybe permit, deny or reject, logging options, and finally the description. By converting Junos XML into a Python dictionary, we can perform clean and accurate comparisons later. In part 6, we have comparing desired with existing policies. That is here, policy matches were reached to this amazing section. This function compares two dictionaries, the policy that already exists on the firewall and the policy we want to deploy from YAML. It checks every single parameter: addresses, applications, logging settings, action, description. If everything matches perfectly, the function returns true, and the script intelligently skips committing that policy again. This prevents unnecessary configuration changes and keeps your SRX devices stable and clean. And after that, finally, we have the main function, add security policy. Here, we are going to review this function that is going to add a security policy to Juniper SRX via PyEZ. This is the heart of the automation. This function performs the full automation workflow for one policy on one device. Inside this function, we have several steps. Step 1 is validating policy fields. It checks that from zone to zone and policy name exist. In step 2, we have building set commands. For each part of the policy, source, destination, applications, actions, and logs, the script builds Junos set commands. After that, in the next step, we are going to connect to the SRX. It opens a NETCONF session using with device. And at step 4, we are going to enter exclusive config mode with config. In the parentheses, we have dev and mode is set to exclusive. And exclusive mode guarantees that nobody else is editing the firewall at the same time. This is so important. In the next step, we check existing policy that it uses the XML filter to fetch the current configuration of the policy and compares it with the YAML data. And after that, at step 6, we have apply configuration. If the policy is new or modified, the script loads the config, shows the diff, commits the change, and prints a success message. And finally, at step 7, we have verification. After committing, the script runs a junos-CLI command. For example, show configuration security policies, and prints the final configuration for confirmation. This entire workflow ensures absolute consistency and reliability. After that, we have the verify policy function. Here, we are going to verify the policy on device. And this function is responsible for retrieving and printing the final applied configuration directly from the SRX firewall. And this step is essential because it gives you 100% confirmation that the configuration is exactly what you intended. And finally, we have the main execution flow at the bottom of the script inside the if name that is assigned to main block. The script loads devices.yaml, loads policies.yaml, iterates over every device, iterates over every policy, applies the policy, verifies the policy, and finally prints a final completion message. This is the full automation loop. And that is the complete breakdown of the Python code behind the Juniper SRX firewall policy automation project. This script is safe, predictable, production ready, and easy to extend. If this helped you, make sure to like, subscribe, and comment your thoughts. Thank you for watching, and as always, don't forget, happy automating.